Good morning, good afternoon. My name is Eran Broshy. I'm the chairman of the American Friends of the Open University of Israel. Welcome, and we are pleased to continue our series of podcasts and virtual salons on issues related to Israel and the world. The Open University, for those not familiar with it, is a nonpartisan educational institution, and with approximately 50,000 students, it's the largest of Israel's 9 accredited universities and the country's largest educator of STEM students. Today, we are speaking with Professor Paz Beniamini, astrophysics professor at the Open University, whose work is in theoretical high-energy astrophysics, a field that explores how nature behaves under the most extreme conditions imaginable. His work uses powerful cosmic events as laboratories for understanding matter, energy, and motion at scales that cannot be recreated on Earth. We're particularly excited and honored to welcome Professor Beniamini today, as he was just awarded the 2026 Blavatnik Award for Young Scientists in Israel in the physical sciences and engineering. The Blavatnik Award is among the most prestigious honors available to early career scientists in Israel, recognizing exceptional promise and awarding one laureate in each of 3 disciplines with $100,000 in unrestricted funding. We will do this today as a conversation in Q&A format, and I'll start with a number of questions. And time permitting, we will be happy to take a few questions from the audience. And to do that, please use the Zoom chat function. Not quite yet, but when we get closer. So let us start. And maybe Professor Beniamini, Paz, if I may, since we're Israeli, so informal is probably easier. Let's start with the Blavatnik Award. You're the first astrophysicist and the first laureate from the Open University of Israel to be honored with this prestigious Blavatnik Award. When you got that news, what went through your mind? What specific piece of research do you feel this prize is really recognizing?
Yeah, thanks, Aaron. Thanks for the introduction as well. It was very exciting. I definitely did not expect it. I was just eating my lunch here on campus with some of the team here, the local team. And I got the call from the Israeli Academy of Sciences, and I was told that I got this prize. So it was a very pleasant surprise. The prize really is not specific to one particular piece of research. And it's more about the general research that I've done, and maybe a good way to say it is that it's about a general approach to the scientific questions that we're interested in. So what I like to do is I'm a theorist, and that means I try to come up with models, I try to come up with explanations of things that we see out there in space, if it's some kind of explosion on a star, or if it's some kind of merger of a black hole and a neutron star, or some system like that. We try to come up with a physical picture. Me and my collaborators try to come up with physical picture of where is the energy released, what is the process that converts the energy into radiation that we can observe, how can you get the relevant conditions that will explain what we see. And then we go and see if this actually matches what people are observing with telescopes. So the way I like to work is to work quite close to observation. Some theorists really like to do theory kind of on its own right, let's say maybe even in isolation from observations, but I actually really enjoy the back and forth between theory and observations. You come up with an idea, and then you say, okay, if you open your telescope at this place, look at this location, in this wavelength, you might see this kind of thing. And then people do that, and they either see it or they don't. And then it's really exciting because you have this feedback. And either way, it's interesting. If they don't see it, it means something goes wrong. So you have to go back to the drawing board. You have to kind of think again. Or maybe they see something, but they see something a bit different than what you expected. So the story gets complicated. And nature is always providing us with more interesting things than we can imagine to begin with. And the nice thing, the unique thing, let's say, about astrophysics is that it's not the case that we can do experiments like in other fields of physics, but we just have to see what nature provides us. Nature does some kind of experiment, and then lets us see something. And then we have to go and figure it out. That's our job.
Yeah. Oh, phenomenal. Very, very interesting. We'll get into the science more in a second, but I'm just curious, how you got intrigued by this whole arena. Was it a specific class? Was it a book? Was it some particular teacher or some moment when, this kind of became to you clear that this is kind of what you wanted to pursue?
So it was not one specific moment where this happened. I was always interested in science, even as a kid. Certainly, my grandparents were a big influence on me getting more into science. My grandfather, in particular, he was born in Germany, a Jewish person born in Germany, and had to escape as a kid to England because of World War II. And he then went into the army as well and fought in World War II. And he never had a chance to study at university. And it was very, very important for him that first of all, for him to kind of keep being in touch with education and learning all of his life, and that we will be able to do these things that he was not able to: go to university, study, and really kind of go as deep as we are interested into one field or another. And so he was a very big part of my inspiration, deciding to go into science in general, and eventually astrophysics. But it was not clear to me from the beginning. I was interested in all sorts of directions of science.
Yeah, phenomenal. Well, I'm sure he would be very proud to see you in this particular moment. Let's jump a little bit more into the science. And your research deals with very concrete phenomena, as you described, the gamma ray burst, fast radio bursts, magnetars, neutron star mergers, etc. If you had to explain this, not to a professional audience, I'm assuming we might have some astrophysicists among our crowd here today, but I suspect not many. But if you had to explain it, say, to a 15-year-old, what these events are, what are the questions you're trying to answer about them, and why they matter for understanding the universe, how would you describe it?
Yeah. So I'll start with the last part. So actually, why would they matter? I would say there are two reasons for that. And one is that, first of all, nature does all sorts of amazing things, and we have a chance to try and understand it, to try and explore it. This is interesting in its own right, even if it doesn't directly lead to some technological application or something like that. But also it is worth keeping in mind that this field of astrophysics, which I work in, which is called high-energy astrophysics, it's really looking at very extreme situations. Let's say particles moving at 99.99% the speed of light. So it's producing all these types of situations that we cannot recreate in laboratory physics. We can reach energies of particles that are way beyond what we can create. We can reach magnetic fields or densities that are way beyond what we can recreate in the lab. So this is a way for us to really explore physics in regimes that otherwise we would not be able to. And when we go to the limits, that's where things get interesting. That's where things might, test our theories, and really we might find that something is different than what we assumed. And maybe going a little bit into a specific example. So you mentioned gamma ray bursts. So gamma ray bursts are these explosions of massive stars that at the end of their lives, they explode. People know about supernovae, but the gamma ray burst is something that happens to really the very specific kind of extremely massive stars. So it's a more extreme event than a supernova. The energy that is released in a matter of seconds. And this energy is about comparable to the energy that the sun would release over 10 billion years, over its entire lifetime. That energy is released in seconds. If this thing happens anywhere in the universe, if it's pointed towards us, because these things are beamed, we will see it. So if it happened 10 billion years ago, somewhere, basically at the edge of the universe, let's say, but pointed towards us, we will see it 10 billion years later today when we open the telescope. And just to think about the fact that these things could exist, I think is just automatically fascinating. At least to me, it is. And when such an event goes off, it's, for example, brighter than the entire galaxy that it's in. For this brief moment, it's brighter than the entire galaxy with 100 million stars in it. It's just it's so fun to think about these things.
Fascinating. I see how excited you get just talking about it.
Yeah.
No, phenomenal. Let's talk a little bit about your career journey, if we can turn in that direction a bit. You've moved through a number of different institutions, both in Israel and abroad. Your studies and early work at the Hebrew University of Jerusalem, then to Paris, then to George Washington University in the US, and then to a postdoctoral fellowship at Caltech before returning to Israel to build your research at the Open University. If you kind of look back through that journey, are there one or two key turning points, a mentor or a key kind of failure or a big risk that you took that most changed the direction of the career you've been taking?
So I have two sort of almost contradicting answers, which I will try to get to. So the first is that I was very lucky to have a lot of people along the way who were mentors and with different specialties. So my PhD advisor and then later postdoc advisors, and even people who were not formally my advisors, but I happened to get into a collaboration with them. Maybe we got started talking in some conference, and we started a collaboration, and in some cases we're still collaborating today. I think I didn't plan this in advance, but I was lucky to really have these people who were extremely knowledgeable, extremely helpful as mentors, and with different specialties. And that kind of unique mix was very useful for me to develop as a scientist. So I said that I have a contradicting answer. So the contradicting answer is that when I moved to George Washington University, this was a really big transition because I moved there to a group which is an excellent group in high energy astrophysics, and all of them are observers. So I was the only theorist in an observer group. And I came almost directly from my PhD, and suddenly I was in a position where people would come to me and ask, I have this observation, what does it mean? And I had to academically grow up. I had to kind of understand that, okay, it's up to me to come up with the solutions here. It's up to me to be the one theorist in the room and to try and understand this as best I can. So this really helped me develop, I think, as a scientist as well, this kind of required level of independence. So in the end, it was a sort of mix of having a lot of mentors, but also kind of jumping in the deep end and having to be independent.
Let's talk a little bit about Israel. You've obviously chosen to come back to Israel after having been at some very, very prestigious places around the world. Talk to us a little bit about astrophysics in Israel, including high energy astrophysics. How is Israel positioned relative to the rest of the world? And then I wanted to ask you a little bit about the academic boycott that's going on more broadly vis-a-vis Israel and how that's been impacting your field and your research.
Sure. So first, in terms of astrophysics in Israel, astrophysics is very strong in Israel. It's due to some key figures, including my former PhD advisor, Professor Tzvi Piran, and others who really helped build the community here, and especially so in high energy astrophysics. The concentration of high energy astrophysicists, world-class high energy astrophysicists that are here in Israel is, per unit area, unlike what you see in most or maybe all other places in the world. One thing led to another. Once you had an established community in this field, then more people are trained in this field, and this whole thing continues. So in that sense, it's a very useful environment to work in because there are many people to talk to who are really experts in different aspects of high energy astrophysics. moving to the boycott and the current situation. So at least I would say in astrophysics, we're relatively lucky that we're not hugely affected by this, not as much as others. We are affected. There are situations where we might not be invited to some conference, or we organized a conference a couple of years ago, and we invited people. 99% of the people we invited came, but there was one or two people who decided not to come for political reasons. So these things happen, and of course, you don't know the things you're not invited to, right? You only know
Sure.
the cases where it's in your face. But on the whole, the community is very international, and it's science first. It's in astrophysics, maybe it goes a little bit with the stereotype of physicists, but we are really not too preoccupied, for better or for worse, with the situation that is happening here, that we're living in, and we'll try to focus our attention outwards to space, not to Earth. So, in this respect, it's also a positive because to do science at a high level, you really have to do it in a collaborative way. You really have to do it in an international way, and you really have to put the science first, not politics.
I imagine the field is highly integrated in terms of globally kind of connected, and conferences are all attracting the key people from around the world to compare and work together.
Yeah, absolutely.
Have you seen it impact other fields of research more dramatically than in your particular arena?
Yeah, my colleagues in other fields, I think, are feeling it more. I've heard stories, certainly in fields like social sciences. I feel it's a lot more prominent. But from my experience, the situation is really the biggest effect that we had is the flight cancellations, and the fact that, I may be invited to go to some conference. This happened to me a couple of weeks ago, and last minute my flight gets canceled, and I end up here and not there. So really, that was in the end the biggest.
Okay. Well, good. Glad to hear that. Let's switch gears and talk a little bit about the Open University and the research center that you run, the ARCO Research Center. Maybe for our listeners who are not that familiar with it, just talk a little bit about what ARCO is, what the research is, what the teaching focus is, and give us a little color on what that all encompasses.
Sure. So ARCO is the Astrophysics Research Center at the Open University. So it consists of faculty members, about between 5 and 7 full-time faculty members, depending how exactly you count. Postdocs, typically we have around 10 postdocs at the center, and then graduate students. So this is a new component because only last year we started a new program, a master's program in astrophysics. And this is actually the first program in Israel which is specifically in astrophysics. Usually when you do a master's in physics, you can specialize in astrophysics, and that's the way it's done at other universities in Israel. But what is unique about this program is that it's really specifically tailored for people who want to do astrophysics, because that's, as the Open University, that's where our focus is, that's where our strength is. And this is now getting to the end of the second year of this program, and it's been a really positive surprise for us to see how much interest there is, and how many students we've been getting, and really good students as well. So the research that's been done here is on all sorts of different topics. We have people working on topics like I do, like explosions in space and things like that. And we have cosmology and large-scale structure and galaxies. And we even have the small scales like exoplanets, evolution and formation of planets, things like that. So really, all fields of astrophysics are more or less covered. And It's a very dynamic environment. The people are here physically in Ra'anana on the main campus, at least a couple of times a week, depending on time of the year and so on. And we have seminars every week. We have advanced courses. We have all sorts of events. And this is it makes a big difference, because like we said before, it has to be a collaborative effort, and that is also true on the institute scale, not just between institutes.
And the grad students and the postdocs that are there, are they primarily Israeli? Are they from around the world? What does that look like?
Grad students are Israeli, except for one at the moment. Postdocs are from all over the world. We have postdocs from the US, from Mexico, India, France. I think that's about it for the moment, but
yeah, no, fantastic. I assume when you were exploring coming back from Caltech to Israel, that there are other Israeli universities that perhaps are more well known in Israel that you were considering. Why did you choose the Open University as the place to make your home?
So in fact, when I was at Caltech, I saw that there was a posting by the Open University that they will have an open position for faculty in physics. And this was not a common thing. I knew that the Open University doesn't advertise for such jobs very frequently. And I happened to know that two of the researchers that were already here, I knew about the research and that they were really, world-class experts in their fields. This, together with this kind of opportunity, which I knew, it's either applying now or not applying at all, because the next open position, who knows when that will be, was what made me want to apply. And I was very happy to join to get the offer to join the university and to do so. So that was really what convinced me, was the people that were already here.
Terrific. Let me give you one more question, and then to the audience, if you have questions that are on the top of your mind to ask of a world-class astrophysicist, this is your opportunity. So put any questions you might have into the chat function. I wanted to just talk a little bit more about the Open University and your perspective. It's a university, the largest university in Israel, as I've mentioned, often associated more for opening doors to students whose paths into higher education are less conventional. And so the question a bit is, after a prize like this recognition, what do you hope people should better understand, both about the university itself and about research at the Open University, and the kind of scientific talent that can emerge when institutions, widen access, maintaining very high quality of academic studies, but opening their doors very, very widely?
It's exactly that. It's exactly the point that people are very familiar with the studies at Open University. And, even last week I was at this ceremony for the award, and there were people there, kind of very distinguished professors from different universities from all over Israel. And at least 3 or 4 times people approached me to say, I'm actually now retired from my university, and I started studying at the Open University. And I have to tell you, this is actually better than my university. And I've heard that really a number of times. And it's that much is something that people, I think, are aware of, that the Open University is a very good place to study. But what I would like people to know is that it's also a very good place to do research. And as you say, it opens the door to people who may not have the most obvious path towards a research career. And I told you that we had the surprise of people who joined the master's degree with how much motivation there was and so on. And a lot of that was because we got people who would not fit to the normal kind of route of doing a master's at other universities, because you have to do it full time. You cannot do it while working. We try to do it where all the classes are in the afternoon or later, and concentrate them in 1 or 2 days a week, things like that. And these are people who are really extremely strong, extremely capable, and I expect that they will produce excellent research. And they would have been lost to science, let's say, if they didn't have an opportunity to do things a little differently. So I think it's like an ecosystem, and
Yeah.
we occupy some special niche in this ecosystem.
Yeah. Fascinating. So a couple of questions have come in the Q&A function. Let me just give you that. One is any application of high energy astrophysics to the question of life outside our galaxy? And then there's one other one. Start with that one.
Yeah, that's a big one. Of course, one of the biggest questions of interest in astrophysics is about life outside of our planet, let alone in other galaxies. It's not obvious what would be the connection with high energy astrophysics, but I can mention one aspect that could be relevant, and that is what people who work on exoplanets have been finding recently is that the conditions that could be suitable for life, that could be suitable for having, say, an atmosphere with the right composition and so on, could depend in part on the magnetic field on the planet, and could depend in part on the core of the planet, the composition of the core of the planet, if it has an iron core, and what fraction of heavy elements are there, and so on. And those heavy elements are produced in those extreme events that we're exploring in high energy astrophysics. And those events are not happening equally throughout space. There are regions where these events are more likely to happen and less likely to happen. And so this could have an impact on where it's more or less likely to find life. There's a competing effect where if you're very close, let's say, to the center of a galaxy where there are tons and tons of stars, the probability that there will be a huge burst of radiation, supernova or gamma ray burst, that will completely ionize the atmosphere and kill all life on that planet becomes too large. But if you're too far away, you may not have the right conditions, all these heavy metals, to get the right kind of conditions on the planet forming. So it's this sort of balance that you have to strike, and that may end up playing a key role in determining how common life is outside of our planet.
So it could help, kind of, in a sense, create a funnel for ruling out and prioritizing certain planets for more likelihood of life. Interesting.
Yeah.
A question that is kind of on the other end of the spectrum a little bit. How might your research affect our everyday lives?
Yeah, so that one again is not obvious. A lot of the connections between theoretical physics and more applicative stuff happens retrospectively, sometimes many years after the fact. But there are ways where it might be possible. I can mention maybe the beginning of an idea that might lead to something. So one of the things that I studied was there is a type of event called a fast radio burst that it's something that I'm interested in exploring and interested in trying to understand what is the origin of those bursts, where the radiation is produced, and so on. And to make a long story short, the big issue with these things is that they are happening at very far distances from us, could be hundreds of millions of light years away. And we are trying to get to understand something that's going on tiny scales, on a scale on the size of a planet, let's say. So it's very difficult to do that. And a few years ago, we came up with a way that you can look at the signature that you see of those bursts. You look at it as a function of the frequency, and due to some pattern that you can see as a function of the frequency, you can learn about the size of the source, and you can essentially constrain the size of the source, even though it's very, very far away. And if you think of it in terms of resolution, if you take something like this, which is the size of a planet or smaller, at a distance of 100 million light years away, this is far, far better resolution than anything that is ever achieved with a human-built telescope, even with the best telescope capabilities. So, can come up with all sorts of analogies, but it's, let's say, seeing something the size of a single hair from the distance of the edge of the solar system or something like that. So it's the equivalent of seeing this very, very sharp resolution. The trick is that you rely on some gas in the faraway galaxy that is essentially acting as a sort of huge astronomical telescope that is located in this faraway galaxy. Now, how can that be translated to something applicative? There's a lot of a gap still between this and there, but it's a hint. It's a hint that there might be something that we can use here also for technological applications, for improving resolution or for doing signal processing or other things like that. So,
yeah, very, very interesting. I wonder if it's similar to the, one of the areas. I don't think it's in exactly the area, but gravitational waves has been one phenomenon where there's been a theory around these gravitational waves, and then there was, I think, a few years ago, a lot of experimentation to actually validate the theory. And to be able to do that experimentation, I think some very, very precise instruments were needed to measure.
Yes, very much so. Yeah,
and that which has led to
build an interferometer which can measure things that are changing on a scale that is less than an atom. Basically, you have these two sides of this huge instrument, and you're trying to measure the tiniest difference between one side and the other. And with these very special techniques that have to do with the kind of balancing of these mirrors with the lasers, you can really get extreme precision, which enables us or enables scientists to do this, to detect gravitational waves, which are now measured routinely.
Exactly, but that also has then applications for other applications besides this particular experiment, which is fascinating. Applications for every day. Let me give you one last question that came in from another audience member, which talks about, in the recent Times of Israel article, when you were receiving the Blavatnik Prize, one of the photos featured one of your paintings of an extreme event in the universe, and it's pretty unusual for a scientist to also be a painter. So, can you talk a little bit about your painting, how often you paint, and how it's connected to your research? A whole nother side of you, Paz, that we have yet to hear about.
Yeah, so it's just a hobby. I'm not a professional painter in any way. My grandmother is a professional painter. On the other side, actually, I talked about my grandfather from one side. This is the grandmother on my dad's side. And she taught me to paint as a kid. And it's something I enjoy doing. It's a way to, kind of get a bit removed from the day-to-day stuff and from maybe some problem that I'm trying to solve, and maybe I get stuck on it. So it's a way to distance myself a little bit from that and find some kind of different state of mind to be in. Sometimes it's things that I paint that have to do with astrophysics, but not necessarily. Mostly it's something I enjoy to do on the weekend.
Phenomenal. Paz, thank you so very much, really, for taking the time. It's evening in Israel, and so taking some of your evening to speak with us about your work, your scientific journey, how your research helps us understand some of the most extreme and fascinating phenomena of the universe, and also to see the impact that grandparents can have on both sides some generations later. The Blavatnik Prize is obviously, it's a wonderful personal achievement, but really it's also a very important moment for the Open University of Israel, which continues to expand its research profile while remaining very, very deeply committed to access to academic excellence and to opportunity. And maybe a reminder that this conversation is a reminder a bit that world-class science can emerge from institutions that open their door quite broadly and invest seriously in talent, in curiosity, and discovery. So I want to also thank you, our listeners, for joining us. Our previous podcasts and virtual salons are also available on the website, our website, AFOUI.org, or on the major podcast channels. And please be on the lookout. We will have additional podcasts, obviously, on an ongoing basis from the American Friends of the Open University of Israel. And of course, more information available on our website or LinkedIn or on Facebook. So thank you all very much. Good afternoon, and Paz, good evening. Good evening to you.